Alright, hello and welcome to a short little video going over how to basically set up the colliders in the virtual robot simulator. So first, going over to the custom configurations here, I'm going to show you essentially just what the colliders do to begin with, which will be shown with the default robot that you get for ultimate goal. So waiting for this to open up here, going to robot configurations, one of the default robots, the FTC ultimate goal example robot here. Just to kind of have an example of how it looks like, the first thing I recommend doing is to kind of show better visuals as to what's happening here, because right now there's blue and red cubes. So I'm going to select the field, which is ultimate goal, to show the corresponding elements that correspond to elements 1 and element 2. So as you can see here, element 1 would be for the rings, and then element 2 here would be for the wobble goal. So starting off with kind of how it works, just essentially just showing the element ones, the rings. It goes through 3 steps through a simulator because we don't want to actually physically simulate the whole thing, because that would take a lot of processing power and a lot of basically physics simulations to get it working. It goes through intaking, then storing then output. So to begin with here for the rings, if any of the elements interact with this collider here, then it will be considered like ready to be intaked into the robot. And then going over to the next part where the storage. So essentially once you are able to intake the rings, it then goes into this storage right here, which will just store it into your robot visually. And then it goes into the output, where right here is basically how it will output out of your robot. So to kind of show, I guess, best how to set it up, I'm actually going to just take a copy of this here and then save it and then just essentially just redo it. So I'm going to actually delete everything here and then do it from scratch. So first of all, make sure that ultimate goal is selected. I'm going to add a new collider. First thing to do is to select which element it's interacting with. This will be the rings, element 1. And then I'm going to place the collider just here for now. And then you can set up like specific things, like for example the rotation. Just set it to -180, for example. Looks pretty good, and I do want to set it back a little bit more into the robot. So I'm going to move it, let's see, I'm just going to type it in, -10, go right into there, and that looks pretty good. It's not exactly centered, which I can do right here. But yeah, overall it's looking pretty good in terms of where it is. Now for this first part here, again, it is the intake, so it'll glow like this to show that it is an intake. And this is just the delay per element right here. So say, for example, if your intake doesn't necessarily work consistently and it is kind of slow to intake, you can change this to only work in like 2-second intervals or something like that. But the important thing is that it doesn't intake all the time. It'll need a certain motor power to activate, or servo power. So right here, if the motor of the ring collection is set to 1, so whenever this is spinning 1 with the power of 1, then this collider will then start working and we'll be able to start intaking rings, which we should be able to see once we finish. So now I'm going to add the second collider here, which will also be interacting with the rings, and I'm going to place it right up here. So this will mainly be for like launching the rings. So I'm going to do output, but I also kind of also want to be able to store rings with this collider here. And as you can see, it is rotated not exactly how we want it to be. So I'm going to put it to, I think, 30 degrees. Looks good to where it's really lined up there. And then I'm going to also center it to be in the middle, and also probably move it up a bit. So I'm going to put it to, let's say, 4 inches. And then that looks pretty good. I think it'll rest nicely right there. And this the same thing with the intake. The output also can have a delay. So even if the motor is powered like 1 for a long time, it'll only go in 1-second intervals each time that it tries to launch the rings. So the velocity, we will actually have a velocity here, and it looks like it'll be a negative velocity. That's probably too much, but this should be based off of pretty much what your like the maximum velocity that these motors here would be able to do, which I haven't calculated, but I can check with the original default robot, and it'll be launched by the ring launcher. So this essentially means that even though the max velocity is like -12 in this direction, that will be multiplied based off of essentially the power of these rings here, or these flywheels here. So then that means that if you want to not launch it as far in a program, then you can just set these ring launchers to essentially be at like 0.5, and then it'll launch a lot less. However, and we can also test it here, which that doesn't look like it's actually enough to launch it. So let me do a little bit more. Maybe -100. I forgot what the scale exactly is. But I think that's a little bit too much. So it's it's very good to have a test right here just to see that the essentially the units are working correctly. And you can see it is working in inches per second. And it's also the case, so there are like kind of two parts to this. One is I guess essentially saying how much it should launch it by. So how much it should launch it by is based off of how powerful the ring launcher motor is, but then it doesn't actually launch it from this section until the ring conveyor is set to power 1. So whenever this ring conveyor is essentially pushing the rings up into these flywheels, then it will be able to output once per every second, and that velocity is then also determined by the ring launcher. Instead of moving on to essentially just storing it, so then we can have up to 3 rings in here. Element type or element limit would be 3, so there'll be 3 of them. It will be in a stack, but it won't be going in that direction. Instead, it'll be going in this direction. I think 6 should be good. There we go. So it's all spaced out and will visually be in there. And again, you can also split up the storing and the output, so you could have it stored like stacked up like right here, but then have the actual launching mechanism be right there. So I think this is all actually looking pretty good. So you can see this will be able to input it, this will be able to output it as well as store it. And now we just need to work on the element 2, which is the wobble goals. So I'm going to place the wobble goal collider. We don't actually have like a visual representation of the wobble goal right here, but it is, I guess technically here is where it would be if we had like a little clamping mechanism here that we're simulating. And I'm just going to make it a little bit smaller just to kind of visually have it there. And I think everything actually looks pretty good. So this will be intaking, storing, and outputting it. And you can see it is actually rotated in the wrong direction. So let me just change that. And also put a little bit more down on the ground. Like this should be good. And so then looking at the intaking, essentially if anything's in here, whenever the we don't actually have the wobble actuator here, so let me just add the wobble actuator real quick, which actually I think it should actually be a servo that will latch onto, which it is actually set to servo. So let me do this. There we go. But yeah, forgot that we actually had the wobble actuator servo there. But moving on to the storing, we'll only be able to store one wobble goal here, which, so then these two options don't really matter that much. And then going into output, essentially it'll just be kind of drop there. So having a 0 velocity is fine, because as you can see, it'll just drop onto the floor as is. It doesn't, this mechanism doesn't necessarily launch it. However, whenever it is let go, that will be whenever the wobble actuator is set to 0. So whenever it is set to 1, it'll latch onto it, and then whenever it's set to 0, it'll output it and let it go. So the wobble goal actuator is actually much simpler in how it works, because it's all kind of in one and it doesn't necessarily launch it, which is pretty nice. So I'll call this the wobble collider, just in case you're coming back to it and you're it's nice to know kind of what everything is whenever you come back to it. So this is the ring launching collider here, as well as the ring intake. Now again, it doesn't really matter to name these, but it is just kind of nice to know what they are in case you ever come back and are confused about what each one of them does. And then again, looking at the effect element 1, it's these two, effect element 2, just the wobble goal here. And yeah, so everything's set up, and so then always make sure to save, and then you can also test it. So going into here, going into the fields, ultimate goal, there we go. And now if we set it up to line up here, we can actually go here. And if we're looking at the robot info, it actually gives us a few info of like essentially what is happening with these colliders. So right now, let me just actually reset everything. It is saying elements in intake 2, but it is occasionally, there we go, had to update it. So if I go forward, should be able to see that elements in intake would be 1. Let me actually check the motor. For the ring collection, it says 5. And you can see that, yeah, okay. So whenever ring collection is 1, that should be going. And you can see that it does activate whenever it is true. However, it isn't actually picking it up, and I think that's just because the ring is a lot closer to the ground than I expected it to be. Alright, so I did update it a little bit, and if I show it here, I did make it a little bit more away from the robot as well as a little bit more down, so it should be able to much better encapsulate the area that it would be able to intake it from. So if I go here and then drive on up to it, you will see that whenever I press 5 and I'm close up against it, then it'll be able to intake it right into the system here. And then now, if I look at the ring launching here, it says element stored. There's 1 element stored, which you can see here. The output is not active, but let me see. So first I need to activate the ring launcher because this will determine how much it's launched by, and then by pressing 7, I'll be able to activate the output and then have it launch. But if I go ahead and go back over here actually, and whoops, let me align it up, and then go this way, and then intake again, and then instead of holding 6 to do the ring launcher, I'm going to go to the ring launcher and then set it to power 0.5 instead. So now, if I power it, it won't be going as fast, and whenever I launch it, it won't go as far. So that's the main reason that you can have a value here, or a motor, that will be able to set exactly what velocity it would be launched at. So all that is working, and that is basically just a rundown of how the colliders work, why they're needed, and kind of how to set them up. So I hope this helped. If you have any questions, please leave a comment, and we'll be sure to get back to you.